All right, we are going to talk about nuclear chemistry today. So, super exciting. Now, first off, we're going to do a quick recap of isotopes. Okay, so up here we have our isotope notation of carbon 12. Now, we know this is carbon 12 because, first off, we see a big C right there, right? That big C is the symbol for the element carbon. So, that's how we know it's carbon. Also, this bottom left number here, that's the atomic number of 6, and carbon has an atomic number of 6. If that 6 was something else, it wouldn't be carbon anymore. Then on the top left up here, we have the mass number. Now, the mass number is the amount of protons plus the amount of neutrons. Okay. Also, rewind a second. The 6 also tells you how many protons it has. And if it's neutral, it tells you how many electrons it has. So back up to mass number. Mass number is protons plus neutrons. So since we have 6 protons and our mass number is 12, that means we take 12 minus 6 and we get 6 neutrons as well. Okay. Now, isotopes are generally identified by their mass number. So that's 12 for this specific situation. So that's why I called this carbon 12. Okay. If the mass number was 13, this would be carbon 13, and so on. Okay. Now, remember, isotopes are atoms of the same element with different numbers of neutrons. So going back up to this, if we had another one here and it was carbon with a 13 in the top left, that would be carbon 13. And the way that it gets to be carbon 13 is it has an extra neutron in addition to the 6 that this one has. So carbon 13 would have 7 neutrons, while carbon 12 has 6 neutrons. Okay. Now, since we have that extra neutron, that's why the mass number goes up to 13 instead of a 12. Okay. So, for example, we have a few here. We have carbon 12, we have carbon 14, we have U-235. So that U is the symbol for uranium. Okay, so this particular version of uranium has a mass number of 235. This one here has a mass number of 238. Okay. To figure out the mass number, like I said, it's protons plus neutrons. To figure out the number of neutrons, it's mass number minus protons. Okay, which again, both of those are given in the isotope notation here. You just take mass number minus protons and you get neutrons. Okay. All right, now, the reason that radioactivity happens is because you have unstable nuclei. Okay, now, the reason that unstable nuclei happen is when you have a really large amount of protons and neutrons in the nucleus. Okay, so generally it happens when you get 84 protons or more in a nucleus. Okay, now the reason that happens is because, as we know, protons are positive, right? So since protons are positive and there's a whole bunch of them bunched together in that nucleus, okay, opposites attract, right? So when we have protons and electrons, they attract together. But when we have a whole bunch of protons put together, they're going to repel each other. Okay. So that repulsion of protons and protons being put together, when there's that many, when there's 84 protons or more in a nucleus, that's kind of starts getting to be too many. And they start repelling each other too much and overcoming the force that keeps them together. And so they start becoming unstable. Now, that instability is what causes radioactivity. Okay, so when the nuclei start getting too unstable, they start shooting off particles from the nucleus. Those particles that get shot off, that's what radioactivity is. Okay, so that emission of particles or energy, okay, or both from the nucleus. Like I said, this is based on the neutron to proton ratio. Okay, so when the nucleus gets too big, it becomes unstable. This process gradually results in more stable isotopes. So what that means, as those nuclei start to get unstable, they start shooting off protons or neutrons or electrons or whatever for the purpose of becoming more stable. So as they get rid of protons and neutrons, that loss of the protons or neutrons makes them more stable.